Hello, Lujane. How are you? I will be your math tutor. My name is Mayss'aa. Okay, we will start by the statistic topic. Okay, so by definition, we mean by statistic? Statistic, it is a study of collection, organization, analysis, and interpretation of data. Okay, we have a topic, we have a question, we do a survey, and the result is a collection of data. Collection, we want to organize this collection of data. We will to analyze and interpret this data. What we mean by data? Okay, a distinct piece of information in the form of fact. The data can be a piece of information, numbers, figures collected, okay? So in a specific purpose, so is called a data. Okay, so the presentation of how to present data can be presented by can be ungrouped data. So it is said to be a raw data. So we have a raw data of numbers. So in this case, we are using ungrouped data. Group data should be given by a table, well organized. Okay, well organized. So good. What is data distribution? The data distribution, they are graphical methods of organizing and displaying useful information. So when we talk about data distribution, so we are interested by the graphical methods. Okay, and we have several types of data distribution as dot plots. So dot plots, from dot we mean that we have dot in this graphic, okay, and so where the dot plot show numerical values plotted on a scale, and we here, for example, in this example, below, sorry. So we have here, for example, dots, 3 dots. What we mean by 3 dots? Normally the study or the statistic, the topic is customer service rating. So we have 1, 3, and 4. We have 1 and 2 and 3. 3 customers rated the customer service as 0/10. And for example, 7 here, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 customers rated 7/10 for the customer service. Okay, it is very easy to explain the dot. What the dot mean? Okay, here. So for the first type can be the dot plots. And we can have, for example, the histograms. Histograms is displayed as bars. Okay, so the height of the bar tells you the frequency. Frequency here mean the repetition, how many is repeated this value. Okay, how much is repeated. So for example, we can have a side-by-side histogram, side-by-side from the term side by side. So we have we have a common survey, or we have a common topic of statistic on 2 different groups or 2 different countries or 2 different teams. So we have a side-by-side histograms to compare results. Okay, so it has helped us to visually comparing the given responses. Back-to-back plot we have two different back-to-back plot, and one of the most useful, useful one is back-to-back stem and leaf plot. Okay, it allows us also for easy comparison of two sets of numbers. So what we mean by back-to-back stem and leaf plot? Normally, column between in the middle, okay, in the middle, like we okay, 0, 1, 2. So how to construct or how to obtain the two different set in blue and set in the right in green. So normally 0 for us is the smallest number here, and we know that it increasingly go in this way, in this direction, 0, 1, and 2. Okay, and for the set on the right, for us the numbers increase in this direction. Okay, we mean by that the smallest value here is 0, 4, so 4, because the next one is 0, 7, it is 7. Okay, because the next is 1, 2, 12. The next is 1, 6, 16. Okay, the next is 2, 7, 27, and 2, 9, 29. In this plot distribution shape, we can say the sets are well organized and arranged, because we know the column in the middle is increasing in this direction, in the right to the right, in the left to the left. Okay, so we know the first or the smallest number, and we know the greater number 20, 29. For the set in the left, so we continue. So the set 1 is 0, 2, 2, 0, 6, 0, 9, 9, and the greater number is 23. Okay, like we say here, like we as it in here. Okay, what is the different shapes of distribution? We have different shape. We have symmetric shape, like a bell. Okay, like a bell. So where the mean and median mode are have the same value, and we have the negatively skewed distribution, and then we have the positively skewed. The negatively skewed, we have the tail in the left, and the positively skewed, we have the tail of the distribution on the right. Okay, we should memorize these different shape. Okay, and we have bimodal distribution. Bimodal distribution shows two peaks not necessarily of the same heights. So normally this is the first example of bimodal distribution, and this is the second one. In the first one, we have two peaks, but not with the same heights. In the second example, we have a distribution, bimodal distribution with two peaks or two identical peaks. Okay, So I will explain median later. Okay, so we will start the exercises. Check your skills. Okay, page 54 and 55. We have here a table. So we have grouped data given in a table. Okay, so in this table, we have country of residence, the number of visitors in thousands, okay, in thousands, in 2010 or 2010, and the visitors and visitors on 2011. Okay, It is very simple. Use the table on the next page showing the top 10 countries of residence of visitors in Australia for 2010 and 2011 to answer question 1 to 3. The country from which most visitors came to Australia in 2011. First, we should know that we are interested by the third column because we are interested in the number of visitors came to Australia in 2011. So we go to 2011 here, okay? And we investigate all the numbers here. The most visitors, the greater number of visitors that came to Australia. So the greater numbers normally is New Zealand because it is a number composed of the biggest number of digits, 1,172.7 thousand. Okay, so from New Zealand. For example, in 2011, I read carefully the table. So we have 1,172.7 thousand came from New Zealand, 542.0 thousand from China, 332.7 from Japan, and 608.3 from United Kingdom. So in 2011, the most visitor came from New Zealand. Okay, good. And the second question, from which country was the increase in visitors from 2010 and 2011 is the greatest? Normally, the term increase from one year to the another. So we have here increase. So we have here a increasing in the numbers. So we have to subtract the two numbers from the visitors in 2011 and the visitors in 2010. Okay, the visitors in 2011 minus the visitors in 2010 in New Zealand, China, Japan, United Kingdom once. Okay, so I evaluate the difference between the 2011 and 2011 and 2010. We obtain these values. Normally, in Japan, we have negative numbers. How to interpret these values? We have negative numbers. So when we have negative numbers, so we have a decreasing and not increasing. Okay, we have a decrease in visitors. We have in Japan decrease in visitors from Japan and United Kingdom from 2010 and 2011. But we have from New Zealand and China, we have increase in visitors from 2010 and 2011. Okay, so we will choose China as the most increasing numbers of visitors from 2010 and 2011. Okay, for what percentage of visitors came from Malaysia in 2010? Normally percentage, we are interested in 2010, so we are interested in this column. Okay, these visitors. Normally, he asked us to evaluate the percentage of visitors of Malaysia. So in Malaysia, from Malaysia came 236.9 thousand. Okay, normally how to evaluate the percentage? Percentage of these visitors came to Australia in 2010 from the sum of these visitors in 2010. So always when we want to evaluate a percentage can always be the current number over the total visitors or the sum of visitors in 2010 by 100. لأنه we are interested in the percent by 100. Okay, so the number of visitors from Malaysia is 236.9 over the sum of visitors that came to Australia from the different countries by 100. We obtain 5.62%. Okay. Which of the following statement about the shape of the distribution in the side-by-side histogram is correct? Normally, side-by-side histogram, yes, we have two bars which are side-by-side. Okay, so to compare result of two groups here. Okay, this histogram group. Which is correct? Group 1 is symmetric. Group 1, so we are interested on the bars on blue, like we on blue, only on blue. We can simply remark that the histogram in blue is symmetric. True, but in group 2 is positively skewed. Group 2 said we are interested in the bars on green. On green, like if we draw the distribution from the top to the top of the next bar, okay, we obtain this form. Oh, okay, we obtain in this form. We have a tail from the left, so we have a tail from the left, so it is negatively skewed. Okay, so when one part, the second part of the first statement of the statement A is false, so the whole statement is false. So A is false, normally positively skewed, so we are talking about negatively skewed, sorry, positively skewed. We mean by that the tail positively skewed, the tail is on the right. Okay, here we have the tail on the left, so negatively skewed, so it is false. Okay, sorry, I have a mistake here. Okay, false here. Okay, B, group 1 is negatively skewed. No, group 1 is symmetric. So when the first, at least one of the one part of the statement is false, so the whole statement is false. So false. Group 1 is symmetric. So group 1 is symmetric, yes, and group 2 is negatively skewed. C, true, negatively skewed. Okay. Group 1 is negatively skewed. No, group 1 is symmetric. When at least one part of the statement is false, so the whole statement is false. So here the two parts are false, so we have a false statement in D. Okay, very easy. Question 6 to 10 refer to back-to-back stem and leaf plot showing runs scored by Michael and Ricky. Okay, normally the topic of this statistic survey is runs scored. Okay, a stem, so the positive direction of the stem is always from top to the okay to down. Okay, and from Ricky is from left to right, and from Michael from right to left, like this. Okay, so for example, the lowest value to Ricky as a score is 0, 0, so 0, but in Michael is 1, 2, 1, 2, so 1, 2 is 12. So Ricky's lowest score, the lowest score are Ricky here. The lowest score is, we begin by this value, 0, 0, so 0, 0, okay, from the stem to the leaf, 0, 0 is 0. So A is the correct answer. Michael's highest score. Michael's highest score. Normally, highest score is in the bottom of the screen or the bottom of the paper or the bottom of the plot. So here, this is the latest value. Leaf, the corresponding leaf is 4. Stem. 4 as a stem and 2 as leaf. So 42. B is the correct answer. Okay. Michael's median score is median. We should know the numbers of runs scored of Michael. How? We count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. 13 as median, 13 different values. When the numbers of data is 13 odd, so we can refer to the slide of median, how to find the median. Arrange the data point from smallest to largest. Normally, in the plot of stem and leaf, the data is already arranged from smallest to largest. If the number of data points is odd, we are in this case is odd, so the median is the middle data point in the list. The median is the middle data in the list. So the middle, we can cancel one from the right, one from the left, and one by one. Okay, one by one to obtain finally, 9. Normally we will if the number is 13, what we can do 13, so 13 we can is odd, we can add 1 and divided by 2, we obtain 7. So the 7th point is the median for us, is seated in the middle of the list. Okay, so 7th here, is 28. Okay, so for us is 28. إذا كان عندي odd, when we have odd numbers of points, we can add 1 and divide the sum over 2. Okay, in this case we obtain the median. The mean, Ricky score, the mean. So how to obtain the mean? The average. How to obtain the average is total, the sum over the numbers of scores or the number of points. How to obtain that? So we should organize or obtain the set from the stem leaf plot. 0, 0 plus 1, 9, 19 plus 23, 28 plus 37, 38, 38, 39, 39, 41, 43, 46, and plus 552 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 over 13. So we will obtain total, the sum over the number, we will obtain 34.1, as a good answer. Okay, so it is very easy to complete by yourself the question 10, the rest of this exercise, and we will have a new recording for the rest of the exercises. Thank you for listening.